So let's start from where we stopped previous class. So we had to start with angle of friction and angle of repose today, and then we'll try and finish this friction part today. How is your preparation going for the module test? You have a module test this weekend, right?
Yes.
So prepare well for it. Uh, do all the chapters which we have covered, which is there in the syllabus. Questions are very simple only. In physics, I have kept all simple questions. But the only thing is you just have to revise everything what we have done. So all the lectures are there on YouTube. You can go and revise it from there as well. So you will find that mostly all the questions we have already discussed in the classes, in the class. So there will be nothing new for you as a surprise. So it's just that you just need to revise everything and keep everything in your mind when you are taking the test. That will help you do better in exam.
Sir,
Ji beta.
so like you send this material of Raksha,
Mhm.
in same way will we get for chemistry and biology?
Yeah, I have asked the teachers to do that. I'll ask if teachers are not doing it, I'll ask Ankit ji to do it for you guys.
Yes, sir. So
So,
because like it's your material and it's quite simple, like it's notes kind of things, so
ji.
we can easily revise through them.
Yeah, that's the whole idea, beta. We should have done it earlier only. Only thing is that I did not get time. Now, chapter wise, I'll keep on doing it. The moment I finish the chapter, I'll upload all the notes and everything, so that it becomes easier for you to revise and practice also. Because there are questions at the back also there, exercise, so that will help you a lot to prepare well. So I'll do it for all the chapters from now on. प्रीवियस वाला तो सब मैंने कर दिया है टिल न्यूटन्स लॉज ऑफ मोशन. आगे वाली चीजें आई विल कीप ऑन डूइंग इट and I'll ask other teachers also to do it. If at all they are not doing it, maybe because of time constraint or something, I'll ask Ankit ji to do it for chemistry and biology for you. Okay. Okay, angle of friction. So angle of friction between the two surfaces in contact is defined as the angle with the resultant of the force of limiting friction F and the normal reaction R makes with the direction of normal reaction R. So see, this is the this is the weight of the block mg. This is the normal reaction and this is the limiting friction. And we saw that the resultant of the normal contact force and the friction force is the contact force, actual contact force, right? So this contact force, right? So this contact force, the angle which it makes with the normal contact force or the reaction force vertical is basically the angle of friction theta. The value of angle of friction depends on the nature of material of surfaces in contact and nature of the surfaces. So this theta depends on the nature of the surfaces in contact. इन दोनों के nature पे depend करेगा and nature of the surfaces. So nature of material and the surfaces whether it is rough, whether it is smooth. Relation between mu and theta, if we see, we know that this limiting friction F, friction force F is equal to mu into R. Normal reaction is R. So mu into R is equal to F. So this value will be F is equal to mu R and this is equal to R. So if I say tan theta is what? AC perpendicular divided by base, AC divided by OA. AC is equal to OB by OA, or OB can be written as friction force by reaction force. Friction force is mu into R divided by R. So R and R gets cancelled. So this is equal to mu. So mu is equal to tan theta. So coefficient of limiting friction between any two surfaces in contact is equal to tangent of the angle of friction between them. Okay. Now, example, if we see a body of mass m rests on horizontal floor with which it has a coefficient of static friction mu s. So we can see that this is a body of mass m, right? It is on rest, it is in rest. Now, yeah. So this is body of mass m, which is at rest on a horizontal floor, with which it has a coefficient of static friction mu s. So coefficient of static friction is mu s here at this surface. As shown in the figure, a pulling force F acts at an angle theta with the horizontal. So this force F is acting at an angle theta with the horizontal. Find the magnitude of F for which block will just move. So we have to find the value of F for which the block just moves. So now we have, what we have done, we have taken a component of this force F in two directions. One horizontal, that is F cos theta, other vertical, which is F sin theta. So एक horizontal component है F cos theta, vertical component है F sin theta. So there is a weight mg acting downwards, a normal reaction n acting upward, and there is this friction force Fs which is acting in the backward direction. So ये जो friction force Fs है, this is mu s into whatever normal reaction is there. So normal reaction के लिए first what we will do, वर्टिकल डायरेक्शन में जो इक्विलिब्रियम होगा तो upward force n plus f sin theta is equal to downward force mg. So this will give us n is equal to mg minus f sin theta. So this is the first equation. Then in horizontal direction, if we see, f cos theta is acting towards right and mu s n is acting towards left. So we have to find the magnitude of f for which block will just move. Just move means f cos theta should be equal to the limiting value of the friction. So f cos theta is equal to mu s into n. Second, put the value of n here. So we will get f cos theta is equal to mu s into mg minus f sin theta. So we have replaced the value of n from equation 1 in equation 2. So this we are getting from 1 and 2. Now f cos theta plus of, just a second. So we are getting this value f cos theta plus of mu s into f sin theta is equal to mu s into mg. F we take it as common, so we will get cos theta plus mu s sin theta is equal to mu s into mg. So F is equal to mu s mg divided by cos theta plus mu s sin theta. Okay. So this is the value of the force which is required to just move this block. Is it clear, bachcho? Now we'll go to the next one. This is similar to what we have done just now. Okay. So this you can do it on your own. We'll do this question. In this, the force is applied from the top. है ना? वहाँ पे force was applied towards, the vertical direction, making some angle. And here it is coming towards the bottom and making angle theta with the vertical. So here n will increase because of this force. In that case, n was decreasing. Here normal reaction will increase basically. So in this case, you can see this force has two component, one along this, so this will be f cos theta, and other which is horizontal, that is f sine theta. Now if we write the equation in both the horizontal and vertical direction, so in vertical direction we have n is equal to f cos theta plus of mg. Okay, how much force is needed to get the block just started? So this is the first equation, and then the force which we need, let's say in the horizontal direction, the force is f sine theta. F sine theta is equal to mu into n, because the friction force has to be equal to the horizontal force on the right for this block to just start moving. Now, if you put the value of the normal reaction from first equation in the second equation, so we'll get from 1 and 2 we have f sine theta is equal to f cos theta plus mg, and there is a mu here, mu into n. So we have f sine theta minus mu into f cos theta is equal to mu mg. So if we take f as common, so f into sine theta minus mu cos theta is equal to mu mg. F is equal to mu mg divided by sine theta minus mu cos theta. So this is the force. So mu mg divided by sine theta minus mu cos theta. Now they are asking, discuss the situation when tan theta is less than mu. So when tan theta is less than mu, we can see that sine theta upon cos theta is less than mu. Sine theta is less than mu cos theta. So this will be sine theta minus mu cos theta is less than 0. So see here, the denominator sine theta minus mu cos theta, if it is less than 0, so whatever the value of f, this is not going to move. Okay. So for tan theta less than mu, f is negative and one cannot push the block ahead, however large the force may be. So the block will not move for any value of force f. तो कितना भी आप force f का value बढ़ा लें, the block will not move when tan theta is less than mu. Is it clear? Have you understood it?
Yes, sir.
Okay, chalo, तो फिर let's go to the next part. Now, angle of repose or angle of sliding. So, angle of repose means as we increase, okay, so as we increase this angle here, so let's say we have a block here. So let us assume this as a block. So I'll just, so if you see this, let's say this is an inclined plane. Okay. So, and there is some, pen which is kept here on this. So this will not move until, so we have kept it horizontal, as we increase the angle, so at one particular angle this pen starts moving, right? At this angle, till the time it is horizontal and you keep on increasing the angle, okay, so at one particular angle this pen starts moving. So that angle at which the block starts moving is basically called the angle of repose. So that's what here it is written here. So angle of repose or angle of sliding is defined as the minimum angle of inclination of a plane with the horizontal, such that the body placed on the plane just begins to slide down the incline. तो आप क्या करते हो, इसको हॉरिजॉन्टल से जैसे जैसे इस एंगल को इंक्रीज करोगे, इस इंक्लाइन के एंगल को जैसे जैसे इंक्रीज करेंगे, एक पर्टिकुलर एंगल पे ये ब्लॉक मूव करने लगेगा डाउनवर्ड डायरेक्शन में, and that particular angle at which the block starts moving down the incline is known as angle of repose or angle of sliding. Now it is represented by angle alpha. Its value depends on the material and nature of the surfaces in contact. In this figure, AB is an inclined plane such that the body placed on it just begins to slide down. So this angle is angle alpha. Now see, this is the downward force mg, the weight of this body. So we can, so basically what we do is we take a component of these forces along two perpendicular direction, one perpendicular to the plane and other parallel to the plane, along the plane. So this is taken as x-axis, this is taken as y-axis. So if we take a component perpendicular to this inclined plane, so we know that this angle is alpha, this angle will be 90 minus alpha, and this angle will again be alpha. So if this is alpha, then this component becomes mg cos alpha, the perpendicular component. The parallel component, which is parallel to the inclined plane, becomes mg sin alpha. Now the friction force, because this block will have a tendency to go down, friction force will oppose that tendency of motion and the friction will be in upward direction. So this is the friction force. So weight mg of the body acting vertically downward, normal reaction R, which is perpendicular to the surface acting perpendicular to AB, and force of friction acting up the plane AB. Plane के ऊपर के direction में ये friction force होगा. So these are the various forces which are involved. And now mg can be resolved into two components, one mg cos alpha, which is perpendicular to the incline, mg sin alpha, which is along the incline. Now if we write forces along the x direction, so let's say this is x and this is y, along x direction if we write it, we have F is equal to mg sin alpha, jitna friction force lag raha hai, because ye object is just about to move, so the downward force will be equal to upward force. Because the object is just about to move, the forces will balance each other. So mg sin alpha becomes equal to friction force, and the normal reaction is equal to mg cos alpha, which is acting perpendicular to the plane in downward direction. Now we have to solve this. This F is equal to mu into R. Okay. So what we have done, we have divided equation 5 by 6. So F is mu R divided by R is equal to mg sin alpha divided by mg cos alpha. Mg and mg gone, R and R are cancelled. So we'll get mu is equal to sin alpha by cos alpha, that is equal to tan alpha. So the coefficient of limiting friction between any two surfaces in contact is equal to the tangent of the angle of repose between them. So mu is equal to tan theta, which is equal to tan alpha, that is theta is equal to alpha. So angle of friction is equal to angle of repose. Okay. So ये जो angle of friction है, this is equal to angle of repose. We have just seen अभी tan theta हमने देखा था angle of friction, और यहाँ पे tan alpha दोनों mu के बराबर है, so both are equal. Now two block systems. So let us consider two blocks which are there on an inclined plane. Now consider two blocks having masses m1 and m2 placed on a rough inclined plane. mu1 and mu2 are the friction coefficient for m1 and m2 respectively. तो इस वाले सरफेस पे फ्रिक्शन coefficient mu1 है और यहाँ वाले सरफेस पे फ्रिक्शन coefficient mu2 है, right? Now, and n is the normal force between the contact surface of m1 and m2. यहाँ पे जो contact forces है, that is equal to n. Now, three conditions arise. First, when m1 m2 is equal to m, दोनों का mass अगर same है, right? So, in this case, n is equal to 0 because both the blocks are in contact but do not press each other. Why? Because a1 is equal to a2 is equal to g sin theta. हम लोग यहाँ पे ना दोनों में we are assuming mu1 equal to mu2 is equal to mu. अगर दोनों का जो ये सेम होगा तभी हम लोग इसमें ऐसे कर सकते हैं. Why? Because we are using single mu here, right? a1 is equal to a2 तभी होगा, दोनों का acceleration same तब होगा जब ये coefficient of friction दोनों का same हो, right? So blocks are in contact but do not press each other. ये तो उस केस में when m1 is equal to m2 is equal to m and mu1 is equal to mu2 is equal to mu. In that case, a1, a2 both will be equal to g sin theta minus mu mg cos theta. So g sin theta इस तरफ लगेगा और फ्रिक्शन फोर्स का mu mg cos theta पीछे की तरफ लगेगा. So g अब यहाँ पे देखो ये इसको सब ये कर लेंगे, डिवाइड कर लेंगे. So a1 is equal to a2 is equal to g sin theta minus mu g cos theta. अगर यहाँ पे m1 और m2 are not same, right? m1 is less than m2. In that case, your n is equal to 0 because there is no contact, right? But a1 will be equal to g sin theta minus mu1. यहाँ पे अब हम लोग दोनों में coefficient of friction अलग मान रहे हैं. तो a1 will be g sin theta minus mu1 g cos theta and a2 will be g sin theta minus mu2 g cos theta. So if you draw the free body diagram here of m1, so the downward force is m1 g sin theta and the friction force is mu m2 g cos theta. And if both are so and if it is accelerating downward, so we will get okay m1 g sin theta minus mu m1 g cos theta is equal to m1 a. m1 कॉमन करके दोनों में काट देंगे. a is equal to g sin theta minus mu g cos theta. वही चीज लिख रखा है, g sin theta minus mu g cos theta. अब यही अगर a1 लिख रहा है तो mu1 यहाँ पे यूज कर लेंगे और a2 सेकेंड ब्लॉक का लिख रहा है, so this is g sin theta minus mu2 g cos theta. Okay. Now if you see this m1, if it is smaller than m2, so in that case a1 will be greater than a2. If m1 is smaller than m2, then a1 is greater than a2. Why? Because see, if m1 is smaller, right, in that case this the value here will have so if it is not m1, it should be here mu1 great smaller than mu2, mu1 smaller than mu2. In that case, because mu1 we are subtracting here, so if mu1 is smaller than mu2, then that case a1 will be greater than a2. Okay. So we'll see a question which will help us understand this concept of two blocks. So here we have two masses m1 and m2 are placed on a rough inclined plane as shown in the figure. Find out the acceleration of the block and contact force in between these two surfaces. So let's say the contact force here between these two surfaces is N. Okay. And these have masses m1 and m2. It is given 1 kg and 2 kg. And the coefficient of frictions also is given and the angle of inclination is also given. Now, what we'll do, we'll draw the free body diagram for each of these. If we draw the free body diagram of 1 kg block, so we have a downward force of 1g sine 37, and this is 1g. This force is 1g cos 37. We have a normal reaction, let's say N1, and here we have mu1 N1. Okay. So basically, if we put the values here, N1 is equal to 1g cos 37. 1g means 10 into cos 37 means 4 by 5. So this is 8 Newton. And mu1 N1, अगर हम लोग फ्रिक्शन फोर्स निकालते हैं, मैक्सिमम फ्रिक्शन फोर्स, mu1 0.5 है into 8, that is 4 Newton. And 1g sin 37 जो डाउनवर्ड फोर्स लग रहा है इस पे, this is 10 into 3 by 5, 15 Newton. Sorry, 6 Newton. ठीक है, 5 2s are 10 and 2 into 3 is 6 Newton. So there is a 6 Newton force acting downward and there is this 4 Newton force. Maximum force क्या है, friction लग रहा है, so this is 4 Newton. So that means this is moving downward, right? Now there is also this force, let's say contact force, which is pushing it downward. ठीक है, let's say this force is N. Okay. Now, if we draw the free body diagram of this 2 kg block, so we have this friction force mu2 into N2. This is normal reaction N2. This is 2g cos 37. We have 2g sin 37. 2g acting downward, and there is this force N which is holding it backward. तो contact force between these two block, वो N इस पे पीछे की तरफ लगेगा. अब हम लोग यहाँ पे अगर इसका जो values है वो लिखें, so here the value downward force is 2g sin 37 degree. Two g sin 37 minus of mu2 n2 is equal to m2 into a. और इस वाले के लिए जब हम लोग इक्वेशन लिखते तो we had 1g sin 37 minus of mu1 n1 is equal to 1 into a, m1 into a. So this is 20 into sin 37 3 by 5 minus mu2, that is 0.2 into n2. N2 is 2g cos 37, 2 into 10 into 4 by 5. 5 to 16 Newton. 2 into 16 is equal to 2 into acceleration A. 12 minus 16 into 0.2. 3.2 divided by 2 is equal to acceleration A. So 12 minus 3.2, that is 8.8 by 2. So this is 4.4 meter per second square. और यहाँ पे अगर हम लोग वैल्यू निकालते हैं, so we have 2g sin, sorry, ये जो फर्स्ट वाले का लिखते हैं 1g sin 37. So 10 into 3 by 5 minus 0.5 into n1. N1 is equal to 8 is equal to 1 into A. So we have 5 2s are 10. So 6 minus 4 is equal to A. So A is equal to 2 meter per second square. तो बेसिकली इसका देखो ज्यादा एक्सेलरेशन दिख रहा है, इसका कम एक्सेलरेशन दिख रहा है. मतलब देयर इज दिस ब्लॉक इज पुशिंग इट फ्रॉम बैकवर्ड, बट दे विल मूव विद अ कॉमन एक्सेलरेशन. Now that common acceleration, if we have to calculate, so in that case, see, we'll have to do this separate thing to find out that common acceleration. So in that case, if you write, so देखो यहाँ पे ये जो n था ना, इस n को भी हम लोग को ऐड करना था यहाँ पे, तो हम लोग को common acceleration मिल जाता, right? So what I'll do, because this is moving with a common acceleration, इसको individually ना करके, if we write it, do it in a, we consider this together as a single mass, it will be easier for you. So let's say this is 1 kg and this is 2 kg, and there is a combined force which is acting downward. 1 plus 2, 3 kg, so 3g sine 37 is acting downward. There is this friction force on this surface and on this surface. There are two friction force. One is mu1 n1, other is mu2 n2. Okay, इसके बीच में जो contact force है, that becomes an internal force now. So this is moving with, let's say, common acceleration A downward. So what we'll write is 3g sine 37 minus mu1 n1 mu2 n2, okay, divided by, so this is equal to 3 into A. Now 3g sine 37 means 3 into 10 sine 37 is 3 by 5 minus mu1 n1. N1 का value is 0.5 into 1g cos. So n1 was equal to 1g cos 37. So 1g cos 37 means 10 into cos 37, 10 into 4 by 5. So this is 8 Newton. And n2 was equal to 2g cos 37. So 20 into, so this will be 16 Newton. So mu1 n1, so 0.5 into 8 minus 0.2 into 16 is equal to 3a. So 3 2s are 6, 3s are 18. 0.5 into 8 is 4. 16 into 0.2 is 3.2 is equal to 3a. Now 18 minus 7.2 divided by 3 is equal to a. 10.8 by 3 is equal to a, or a is equal to 3.6 meter per second square. So because both these blocks are moving together, so we have a common acceleration. So that is equal to 3.6 meter per second square. Now once you have got the common acceleration, now you can find the normal reaction by drawing the free body diagram of individual blocks. So the downward force here is 1g sine 37, and there is a downward force of normal reaction n here. Friction force is mu1 into n1. So if we write this, we know that, and it is, let's say, accelerating downwards. So we have 1g sine 37 plus of n minus mu1 n1 is equal to 1 into a. अब इस पे वैल्यूज पुट कर लेते हैं. 10 into 3 by 5 plus normal reaction n mu1 n1, right? Mu1 n1 is 0.5 into 8 is equal to 1 into acceleration is 3.6. So 6 minus 4, n plus 2 is equal to 3.6, or normal reaction is 3.6 minus 2, that is 1.6 Newton. Is it clear to everyone? Clear है बच्चों?
Yes, sir.
Let's go to the next one. Now in this question, basically, we have to find out in which direction the body will move. So see, this is 37 degree and the mass is 10 kg. We assume that the body is moving in this direction, downward direction. Okay, so when first case, we'll assume the block to be coming in this direction and this block going upward. और उसमें निकालेंगे एक्सेलरेशन. अगर एक्सेलरेशन पॉजिटिव आ गया तब तो ठीक है, नेगेटिव है मतलब कि हम लोग का उल्टे डायरेक्शन में होगा. So let us consider this. Two blocks of masses 5 kg and 10 kg are attached with the help of a light string and placed on a rough incline as shown in the figure. Coefficient of friction are as marked in the figure. The system is released from rest. Determine the acceleration of the two blocks. So we have to find the acceleration of both the blocks. So if we draw the free body diagram of this block, 10 kg block, we are making the free body diagram. So we have 10g sine 37, tensor T, and the friction force is acting downward. So this is mu1 into n, n1 basically. Let's say this is n1 and this is 10g cos 37. If we write the equation, see 10g cos 37, n1 is 10g cos 37, 10 into 10, cos 37 is 4 by 5, 80 Newton. Okay. So we'll have, let's say this is moving downward with an acceleration A, and this is moving upward with an acceleration A. Now if we write the equation for the 10 kg block, so what we are going to get is 10g sine 37 minus T minus friction F1 is equal to 10A. Now put the values here. We will get 10g sine 37 means 10 into 10 into sine 37 is 3 by 5, minus of tensor T, minus of friction force, that is mu1 into n1, 80. mu1 कितना है? 0.3 is equal to 10A. So 5 2s are 10, 20 into 3, 60 minus T minus 24 is 10A. 60 minus 24, 36 minus T is equal to 10A. This is the first equation. Now we draw the free body diagram of the second block, 5 kg block. So यहाँ पे इस डायरेक्शन में नॉर्मल रिएक्शन N2 होगा, इधर यहाँ पे 5g cos of 50 डिग्री हो गया, ठीक है. अच्छा 37, दिस इज 53 डिग्री, ठीक है. cos 53 डिग्री कर लेते हैं. और अब इस पे जो इधर डायरेक्शन में फोर्स लगेगा, दिस इज 5g sine 53 degree. Okay, and then because it is going up, इस पे जो friction force लगेगा F2, this is equal to mu2 into N2, and there is this tension force T acting upward, and the acceleration is in this direction, going upward. The block is going upward. So we'll have normal reaction N2 will be equal to 5g cos of 53 degree. So this is 50 into 3 by 5. So 10 3s are 30 Newton. So we have T minus 5g sine 53 minus mu2 N2 is equal to M2A. T minus 50 into 4 by 5. Mu2 is 0.1 into N2 30 is equal to M2A, 5 into A. So we'll have T minus 40 minus 3 is equal to 5A. Or the equation is T minus 43 is equal to 5A, second equation. तो इन दोनों को आप सॉल्व कर लेंगे, मतलब 36 minus T is equal to 10A, T minus 43 is equal to 5A. If we solve these two, add these two, plus T minus T gets cancelled. 36 minus 43 is equal to minus 7 is equal to 5A, or A is minus 7 by 5. So this is, sorry, 15A. Minus 7 by 15. So in this case, you can see that A is negative. ठीक है, तो A नेगेटिव आ गया, तो मतलब ये ऑब्जेक्ट इस डायरेक्शन में नहीं, उल्टे डायरेक्शन में मूव करेगा. अगर उल्टे डायरेक्शन में if we solve this, you will find again A to be coming negative. हम लोग करके देख लेते हैं, है ना. तो ये हो गया हमारा जब when we have assumed the object to be moving, you know, in this direction, 10 kg going down the incline and 5 kg going up the incline. अब इसके ऑपोजिट वाला केस हम लोग एज्यूम करते हैं, ये तो नेगेटिव आ गया. ऑपोजिट केस में लेट अस एज्यूम दिस मूविंग डाउनवर्ड एंड दिस मूविंग अपवर्ड. अब हम लोग जो इसका इक्वेशन लिखेंगे, सो दिस इज टी हियर, राइट. फ्रिक्शन विल बी डाउनवर्ड एंड देयर इज दिस वेट का कंपोनेंट इन दिस डायरेक्शन. इधर आ रहा है, यहाँ पे फ्रिक्शन अपवर्ड हो गया, टेंशन टी हो गया, और वेट इस डायरेक्शन में हो गया. सो इसका इक्वेशन पहले लिखते हैं, टी माइनस 10g sin 37, okay, minus mu into 10g cos 37 is equal to 10a. और दूसरा हम लोग लिखते हैं इसमें 5g sin 37 minus t minus mu2 into 5g cos 37 is equal to 5a. अब इसको हम लोग सॉल्व कर लेते हैं. इसको सॉल्व कर लेंगे तो प्लस टी और माइनस टी कैंसिल हो गया. सो 10g sin 30 minus 10g sin 37 plus 5g 37, तो माइनस 5g sin 37 हो गया. और ये माइनस μ1 माइनस μ2 माइनस μ1 into 10g cos 37 minus mu2 5g cos 37 is 15a. तो यहाँ पे भी a देखोगे तो नेगेटिव आ जाएगा, सारे टर्म्स नेगेटिव हैं यहाँ पे, राइट. सो a इज अगेन नेगेटिव, तो मतलब द बॉडी इज नॉट मूविंग इन दिस डायरेक्शन ओनली. सो इसका मतलब क्या हो गया, एक्सेलरेशन ऑफ टू ब्लॉक्स क्या हो जाएगा, 0 हो जाएगा. द बॉडी विल नॉट मूव सिंस acceleration is negative in both case. So this is very important. Because the acceleration is negative in both cases, this implies the blocks are not moving at all and are stationary. Clear है बच्चों? Is it clear to everyone?
Yes, sir.
Yes, sir.
Now we'll do this two block system on a horizontal surface. So in these question, we have done such kind of question. You can attempt this question once. Okay. Try doing this question and tell me the answer. What is it coming for you? देखो यहाँ पे अगर हम लोग कोशिश देखते हैं इसको, तो block of mass m is placed on another block of mass capital M lying on a smooth horizontal surface as shown in the figure. The coefficient of friction between the blocks is mu, मतलब इस वाले surface पे coefficient of friction mu है. What is the maximum horizontal force F that can be applied to the block M so that the blocks move together? तो आपको ये देखना है कि ये दोनों ब्लॉक जो है साथ में ही मूव करें. तो साथ में मूव करने के लिए मान लो दे आर मूविंग टुगेदर विथ एन एक्सेलरेशन a, so F will be equal to m plus m into a. ठीक है, यहाँ पे जो सरफेस है दिस इज स्मूथ, यहाँ पे कोई फ्रिक्शन नहीं है ना, स्मूथ हॉरिजॉन्टल सरफेस बोल रखा है. सो ये F is m plus m into a, so a is equal to F divided by capital M plus small m. This is the first equation. Now if you draw the free body diagram individually of the bigger block and the smaller block, we did a similar question in the last class also. So देखो ये दोनों ब्लॉक जो हैं, अब ये ऊपर वाला ब्लॉक, ठीक है, बिकॉज ये इस पे स्टेशनरी फोर्स हम इधर लगा रहे हैं, तो बिकॉज इस पे फोर्स F इधर लग रहा है, तो जो फ्रिक्शन फोर्स है वो इस वाले सरफेस पे पीछे की तरफ लगेगा F, और जो ऊपर वाला ब्लॉक है उस पे फ्रिक्शन फोर्स आगे की तरफ लगेगा, ऑपोजिट डायरेक्शन में हमेशा लगता है. सो स्मॉल m पे फ्रिक्शन आगे की तरफ और कैपिटल M पे फ्रिक्शन पीछे की तरफ लगेगा. और इसीलिए क्योंकि रिलेटिव मोशन को अपोज करता है फ्रिक्शन हमेशा, तो इन दोनों का रिलेटिव मोशन ऐसा है कि ऊपर वाले ब्लॉक के रेस्पेक्ट में नीचे वाला ब्लॉक आगे मूव कर रहा है, तो इसीलिए इस पे फ्रिक्शन पीछे की तरफ लग रहा है, और नीचे वाले ब्लॉक के रेस्पेक्ट में ये वाला ब्लॉक पीछे की तरफ जाएगा, इसीलिए इस पे फ्रिक्शन आगे की तरफ लगेगा. नाउ इफ वी see now this force is mg downward and the normal reaction is n, F is equal to mu into n. We have to find maximum force that can be applied so that, अच्छा ये जो acceleration इसका a होगा, तो जो friction force F है, this will provide that acceleration a, common acceleration a to the upper block. So this is mu n, this mu n is equal to m into a, जो mu into n means mu mg is equal to ma, और we have to find a is equal to, ये mu g हो गया. a का वैल्यू हम लोग को पता है, F divided by capital M plus small m is equal to mu g, right? If you combine first and second, so we will get F is equal to mu times capital M plus small m into g. So this is first option, the maximum value of the force. Is it clear, Bicho?
Yes, sir.
Try doing this next one. उसी में वैल्यू डाल देना है बस. It's same as the previous question. You just have to put values.
For 29.4 Newton.
You have taken G as 9.8.
Yes, sir.
अच्छा अच्छा, 10 लेके करो 30 न्यूटन आ जाएगा.
Yes, sir.
Correct है. So find out the maximum value of force F for which both the blocks will move together. So F is equal to 2 plus 4 into acceleration A. So this is F by 6 is equal to acceleration A. अब ऊपर वाले ब्लॉक पे अगर हम लोग बनाते हैं mu into 2g is equal to, So mu into 2g is equal to 2a. Mu is 0.5 into 20 is equal to 2 into f by 6. So f is equal to 10 into 3, 30 Newton. Now in the same question, you have to find in the above question, find the acceleration of both the blocks when F is 18 Newton and F is 36 Newton. देखो मैक्सिमम फोर्स जब दोनों साथ में मूव कर सकता है वो हम लोगों ने निकाल लिया कि 30 न्यूटन होगा. पहले केस में कह रहा है ये फोर्स अगर 30 न्यूटन से लेस है तो दोनों साथ में मूव करेगा. अगर फोर्स 30 न्यूटन से ज्यादा है तब दोनों साथ में नहीं मूव करेगा, नीचे वाला ब्लॉक नीचे से खिसक जाएगा आगे की तरफ. सो द लोअर ब्लॉक will move forward for a force greater than 30 Newton. So that's what you have to find. You have to find the acceleration in both these cases when the force is 18 Newton and 36 Newton. Please calculate and let me know.
For first one, it's 3 meter per second square.
Yeah, first one is correct, 3 meter per second.
And for second, it's 6 meter per second square.
दोनों का अलग अलग होगा बेटा.
Also 6 meter per second square.
That's what I'm saying. The second case में both the blocks will have different acceleration. Because it is greater than 30 Newton, they will not move with the same acceleration.
Okay, okay.
You will have to draw free body diagram separately for them.
So for block A, it is minus 8 meter per second square.
नहीं, नेगेटिव में नहीं आएगा, हम लोग को उसका मैग्नीट्यूड बताना है. I'll do it for you. In the above question, find if both the blocks find the acceleration of both the blocks. So first one, because it is less than 30 Newton, it will move together. So acceleration A for the first case is F divided by capital M plus small m. So F is equal to 18 divided by 2 plus 4. So 18 by 6 is equal to 3 मीटर पर सेकेंड स्क्वायर. फर्स्ट वाला तो ठीक है. सेकेंड वाले के लिए अब अगर हम लोग बात करें तो इसका अलग अलग हम लोग फ्री बॉडी डायग्राम बनाएंगे. सो पहले हम लोग 2 kg वाले का फ्री बॉडी डायग्राम देखते हैं. सो दिस इज 2g डाउनवर्ड्स, n upward, and then we have this friction force acting in the forward direction. F is equal to mu into n. Mu is 0.5 into 220. So that is 10 Newton. Friction force is 10 Newton. So F will be equal to small m into A. So this means 10 is equal to, this is small m into A1. ऊपर वाले का acceleration A1 मान रहे. 10 is equal to 2 into A1 or A1 is equal to 5 meter per second square. Now for the lower block, if we see, we are applying a force 36 Newton here. And then we have this friction force acting backward. F is equal to 10 Newton. It is moving with an acceleration A2. So 36 minus 10, the force which we are acting, force which we are applying. So 36 minus 10 friction force is equal to mass capital M into A2. So 26 is capital M means 4 into acceleration A2. So the acceleration A2 will be 26 upon 4. So this is 13 by 2, 6.5 meter per second square. Is it clear? Is it clear, bachcho?
Yes, sir.
Yes, sir.
Okay. Now try doing this. So we have to find the range of force in which both the blocks move together. So till what force, till what value of force, starting from what value to what value of force F will the blocks move together? There is friction at both the surfaces. Bottom में भी है और blocks के बीच में भी है. So in this question, find out the range of force in which both the blocks move together. So first we'll find out ki when the amount of force required to make this block move, the both the blocks to start the motion. So for that, let's say these blocks, we consider this as a system. So the total force which is acting downward, so this is 2 kg and this is 4 kg. Total force acting downward is 6 kg. So the force is 6g, right? And we are applying a force F. There is a coefficient of friction 0.1 in this direction. So mu1 into normal reaction, let's say if we are taking n here in this surface. So basically F is equal to mu1 n. This is the minimum force required to start the motion. F is mu1 n. Force F will be equal to mu1 kitna hai? 0.1 into, and n is equal to 6g, that is 60 Newton. So 0.1 into 60 Newton, that is 6 Newton. So minimum force required for the block to move together is 6 Newton. So F should be, this force, applied force should be greater than 6 Newton, right? So you will write for 0, between 0 Newton and F lying between 0 Newton to 6 Newton, both the blocks, no blocks will move. Okay. Now next we have to find the force at which both these move together, the maximum force. So maximum force which is acting so that both the blocks move together is, so here F is equal to capital M plus small m into acceleration A. So F is equal to 2 plus 4 into acceleration, let's say common acceleration is A. So capital F is equal to 6 into A. And I'm sorry, we will draw the free body diagram separately of 2 kg and 4 kg block. So for 2 kg block, if we draw, there is a friction force acting in the forward direction, mu2 into n2. So let's say normal reaction n2 is acting here and n1 is acting here. So mu2 into, sorry, and the weight is acting here, 2g in this direction. So n2 will be equal to 2g, that is 20 Newton. So mu2 n2 means 0.5 into 20, that is 10 Newton. So 10 Newton is the maximum friction force. And at that friction force, this block is moving with an acceleration of, maximum acceleration is equal to this friction force which is acting here. So let's say the friction force acting here is F2. So F2 mass m into acceleration is F2. So maximum acceleration is equal to friction force which is acting 10 Newton divided by the mass of the block 2 kg. So this is 5 meter per second square. So 5 meter per second square is the maximum acceleration for which both the blocks will move together. Okay. So we have to find the range of force. So force required for this to move at this acceleration. So we'll have, see, both the blocks kept here. Friction force acting down backward. F is equal to 0.1 into n. So total 6g. तो जो n है वो 60 न्यूटन हो गया. 0.1 into 60, that is 6 Newton. This is a friction force 6 Newton acting in the backward direction. So capital F minus friction force 6 Newton is equal to, both the blocks are moving together, 6 into 5. So F is equal to 30 plus 6, that is 36 Newton. So the maximum force which we are applying so that both the blocks move together is 36 Newton. So that means for 6 less than 6 Newton less than F less than 36 Newton, both blocks move with common acceleration. क्लियर है? तो हम लोगों को यही रेंज निकालना था, फाइंड आउट द रेंज ऑफ फोर्स फॉर विच बोथ द ब्लॉक्स मूव with a common acceleration. So the range of force is lying between 6 Newton and 36 Newton. 6 Newton तक तो मोशन ही नहीं होगा और 6 से 36 तक ये कॉमन एक्सेलरेशन से मूव करेगा और बाद में फिर जैसा पिछले क्वेश्चन में किया हम लोगों ने, दोनों अलग अलग एक्सेलरेशन से मूव करने लगे. क्लियर है बच्चों? समझ आ गया आप लोग को?
यस सर.
ठीक है, तो वील स्टॉप हियर और फ्रिक्शन फोर्स में इतना ही है. एक स्यूडो फोर्स के कॉन्सेप्ट का 2 क्वेश्चन हम लोग अगली क्लास में कर लेंगे, जिसमें स्यूडो फोर्स भी कंसीडर करेंगे फ्रिक्शन फोर्स में. वो क्वेश्चंस करने के बाद आई थिंक कि यू विल बी एबल टू सॉल्व ऑल द क्वेश्चन ऑफ फ्रिक्शन फोर्स. ओके, और सर्कुलर मोशन हम लोग अगली क्लास में स्टार्ट कर लेंगे फिर.
सर ये रिकॉर्डिंग का लिंक भेज दीजिए.
हाँ, आई विल सेंड इट. ठीक है, कौन से वाले, पहले वाले या ये वाला?
सर ये आज जो हमने चैप्टर किया उसकी रिकॉर्डिंग.
हाँ हाँ, मैं भेज दूँ. ठीक. ओके बच्चों, बाय एंड टेक केयर एवरीवन.
ओके सर.